Hey, what's up, everybody? Today is March 12th, 2025. Again, uh, I did yesterday's daily. I'm going to try and do today's daily. We'll see how it goes. Let's go ahead and practice our type racer and get to it. Oh, that's weird. It signed me out. One second. I don't know why I did that. I was just logged in. Okay. All right, let's do this. Wow, these words are hard. Come on. I know what all the letters are. Let's do one more. I didn't like that. Oh, that was better. Man, the typos kill my words for a minute. I mean, look at these burst speeds I have. 140s, 130s, 120s. And then, boom, typos. Every time on the typos. Okay, let's go ahead and try our Leetcode. Three, three, five, six, zero array transformations 2. You're given an integer array nums of length n and a 2D array queries, where queries I is left, right, and val. Each query I represents the following action on nums. Decrement the value at each index in the range left or right in nums at most val I. The amount by which each value is decremented can be chosen independently for each index. A zero array is an array with all elements equal to 0. Return the minimum possible non-negative value of k, such after processing the first k queries in sequence, nums becomes a zero array. Honestly, I don't even know what they're really asking. Let's see. Nums 202, the queries. Okay, explanation. For I equals 0. Zero to 2. At most by 1. Decrement values at indices 0, 1, and 2 by 1, 0, 1, respectively. This array will become 101. For I equals query of 1. Okay, and there was 2. We did 2 queries. All right. 4, 3, 2, 1. Value of 2. you can have 10 to the 5 queries. Four, three, two, one. So everything from 1 to 3 is 2. Everything from 0 to 2 minus 1. Doing every query won't work. I get what they're asking, but I don't know how to do it in a time-efficient manner. I literally have no idea how to do this. Because the problem is it's asking for how many queries for K, right? After processing K queries in sequence. I wonder what would happen if I binary searched K, assuming it's valid, and then checked if nums is all 0 by K, right? So if valid of whatever, we're looking for the smallest K query, right? Of 10 to the 5, right? So then we go um, if it's valid. Okay, if we find it valid, then we want the minimum. So we want to go left. Right? If it's not valid, then we want to go okay. Valid means that all nums is 0 for k queries. Right? So we had to go far enough in right to get all valids. All valids to the right. So it goes not valid, not valid, not valid, 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 right? If it's not valid, it's on the left side, which means we need to go to the right. So it's I can do left equals mid plus 1. And then this is going to be result equals mid. Right? Okay. Which turns it from, it's like a in login kind of deal. Login checks here. Queries. Okay, so now how can we check to make sure all the queries will zero this out? Do I manually check it or do I line sweep it? Okay. Okay, so we don't really need to take nums in, and we already have queries. So we really need to check up to a point. So from whatever left is to right, queries. Yeah, from 0 to 2, 0 to 2, 1 to 3. Is this valid? Can I do a vector and then an O of N search? So if I do, well, first off, we need to pass in mid the index. And mid is going to be the right value. Or no, it's going to be K. Oh, from queries, yeah, so we can say K. And then we can say vector int check. It's going to be K values. Doesn't matter. K plus 1 values. And they're all going to be set to 0. And then we're going to say, we're going to put 1, 1, 3, like that. So this is 1. This is 2. Oh, in the ranges, right? Because we're only curious about if this is zeroed. Actually, couldn't I just say nums in? Yeah, I can just say nums. I can just say check full nums. And then for in value 0, I is no, because then I would have to check them all individually, right? I don't want to do that. And then it's just positive weight, a running weight. Yeah. So we go check. Yeah. K plus 1, 0. Okay. 0 is less than K. I plus plus. Whatever, it doesn't matter. Okay, so we go for the I less than K. And then we say queries. Okay, so we have 0 start. So we'll put check I 0. Okay, so this is the initial position, I0, right? But this is from queries. Okay. This is the starting position. Plus equals whatever this value is, which is 1. Oh, no, sorry. Okay. So we have 0 and 2 as 1. Well, actually, do we even need the end mark? Oh, no, so this is minus equals, right? Yeah. So you start, add 1. 2, subtract 1. But this should be the next thing we add or subtract 1, right? So it's 0 to 2, it's 1. Then this is plus 1. Yep, like this. All right. And then this gives me all the values for this. Then we can just go a for loop. Or where do I go? Bool equals all are true. Or if running no. Oh, I'm sorry. If nums, this is wrong. If nums is greater than running. Right. Memory limit exceeded. Is it because I'm doing this every time? Can I do this? No. Hold on. I don't need to bring L or R into there. Right? Well, first off, let's go 1e to the 6. And then let's go ahead and pass these down, because this is for the binary search. Not valid. What? Misaligned. In K, which is mid. An int, which requires 4 bytes. Queries. Where's it breaking? It's not this, is it? Oh. Oh, what do you mean misaligned? Val I is only 1 to 5? So the most it can increment or decrement is 5. Okay, the binary search isn't the issue. I0. We're going through K queries. I0 is the starting index. And we want to add 1 to it. This is the ending index. And we want to subtract it from the next value. And we're going through I through 0K. Check is based on the queries. We want to go through nums. Okay. Check is only 0 to K. For the queries, obviously. But check is wrong. Check is not K. Check is nums.size. Oh, I have to add 1. Okay, this is K queries. We don't want to go to the last one. Okay, running. Wait, no, we do. Hold on. What am I doing wrong? Which for loop is killing me? I equals 0, I is less than K. Oh. Maybe that's what I'm doing wrong. The max this can be is queries.size. Okay. This is -1. Well, that's a good point. I never even thought about -1. Yeah, if I find nothing, this should just be -1. Right? Right, so we binary searched the K on the answer. And then we created a vector. We did the weird running track thing. And then we compared it to running. Let me explain what I did. So we have a bunch of queries. We're going to just use the first one example, 202. Is our nums. And what I did is I basically set up another value thing with an additional value because I need to set the negative value at the end, but I'm never going to actually use it. So then I binary searched as my answer, saying K is the minimum spot that has to be valid. And I checked to see if it's valid. So we're taking the midpoint, which is 0, 2, 1, right? Or it's just 1. And we're saying everything up to here, all queries up to here, if this makes it 0, this is a potential answer. And if it is an answer, we're going to go ahead and now check the left side to see if there's a better answer in the middle. You know, as a binary search. And when I'm checking 0, we're doing a line sweep. This is a form of line sweep anyway. Where we're adding the start and subtracting off the end on the next value. So we have the start of 0. This is what's going to make the index. We're going to add 1 to it. And then the end is 2. So 0, 1, 2. Then this is going to be negative 1, right? So we're adding the start. And then on the next value, we're subtracting 1. Okay. Then we're going to go to the next one here. And we're going to say, we're going to do the exact same thing. Now remember, this is what the for loop's doing. It's checking each query. So we're only doing O of n queries. So we're going to add 1, 2. Then we're going to subtract 1, negative 2. Okay. Now, when we take a running value, this is sort of like a prefix sum, right? We're going to be like, so we're going to add 2 to the running. We're going to compare it to this value, 2. Okay. And we're going to say, well, let's just do the whole thing first. So it's going to be 2, 2, 0. We're going to say, we're going to compare it to 202. And we're going to say, is the running value, or I'm sorry, is the original nums_i, this value here, 2, is it greater, is 2 greater than 2? Okay? If this value is ever greater than this value that we added up from our queries, then we know that we cannot zero out the value with our new value, right? So this is basically our weights. We're zeroing out nums using this, right? And then this subtracts it off. As you can see at the end, it becomes 0 because we subtracted it off, right? So this is basically the first example. And we know that when we go up to the mid, we know that this is valid. So the mid is valid at after 2 queries. So 1, 2. However, we're not quite done yet. So what we're then going to do is we're going to say, okay, well, if the middle here is valid, let's go ahead and check a smaller value, like this one, as our new valid. So we're going to go ahead and go shift our right over here as our boundary. So we have left 0, right 0. And then we're going to say, is this valid? It's not valid. And at this point, left is less than right. So we're going to go ahead and break. And when we break, we can return the smallest value going to the left. Okay? Yeah. This type of line sweep I learned not too long ago. So I'm kind of happy I was able to apply it. There is another line sweep, but we'll have to wait until another problem occurs that uses the event style line sweep, which I like that one too. It was the first one I learned. Anyway, let's go ahead and submit our solution, see if it works. Oh my goodness, it didn't work. And it's probably something to do with my binary search, right? I don't think it's this that's broken. Mm, right. Output is 2. Expected 1. 0 is 5. Oh, I have to be able to get 0, first off. I don't think that's going to make it work, though. Oh, it does. I always get mixed up by while less than or less than or equal to. Oh, okay, there we go. Whew, that problem scared me a little bit. I was seeing people solving some of it and I was kind of ignoring it, but everybody was talking about binary search. And I'm like, I don't know. And then as soon as I seen K, I'm like, oh, it's binary search on the answer. Which then led me to, oh, it's a line sweep. I don't think this is the most efficient. I think people else had probably done it more efficiently. But we're going to go ahead and look at that later. All right, anyway, thank you for joining me for the actual daily today. Yesterday's daily was a little earlier, but I still made it in time. I hope you join me next time. Have a good day. Peace.